All right. Good afternoon, everyone. Thanks for giving me the chance to represent my work. So here are my topics that I'm going to talk about today. My first topic is geographic and topographic distribution of wind velocity, and then we're going to talk about area of application for the wind velocities and the type of wind turbines that we have. So let's talk about the objectives of this presentation. Of course, as I said, we're going to talk about wind distribution, and then I'm going to talk about explain little bit the geography and topography of areas, wind speed, how it is affected by the topography, and area of application, and finally the types of wind turbine. So let's talk about wind distribution. Uh, to understand this phenomena, first we need to understand how wind works, like what causes it to flow. So the main reason why there is a wind outside is because of the pressure difference, and that pressure difference is caused by heating by the sun. So we have solar power, and then there are some areas that some are close to the sun and some are far from the sun. So we have uneven heating, and that heating difference actually causes high pressure and low pressure. And the reason why air moves the way it moves is like when you heat a part of atmosphere, basically the air molecules, they get high energy, they expand, and it becomes like less dense, and the particles, the hot air, it's usually rises. So when it goes up, there is low pressure at the bottom. So the as we all know, the air moves from high pressure to low pressure. So from the other side, where there is a less pressure, as we can see in this picture, if we talk about ocean and land, the land gets warmer faster than the ocean. So here we have a pressure difference. You can see there is a warm air on the land and there is a cold air in the sea. So when the warm air rises, the air that is more dense and cool from the ocean that comes in starts flowing from low pressure, high pressure to low pressure. So this is how this continuous motion of air is generated. So this is how it keep moving all the day. So let's talk about the mountains. As we all know, as we go high above the mountains, we have low temperatures. The weather is like a little cold. So as I already discussed, if the weather is cold, the air, of course, is gonna be dense, and dense air is just goes toward downward. It doesn't rise above the air; it falls down. So the air actually flows down the mountains, hills, and there is you can say uh, high pressure underground from the air that are coming from the upside and mountains. Let's do some let's do some practical experiment. Like I would just ask you guys to hold a hand in front of your mouth and just blow some air. Did you do it?
Yes.
So if you blow the air on your hand, you will notice there is a warm air. Okay. So now I want you to repeat this experiment again, but this time just make a tight O with your lips, like make that the place smaller, and try to blow again. And this time you're gonna notice that the air is cooler. And the reason being, as I already explained, when there is less area, you're gonna blow the air, it's gonna get compressed, and the compressed air is cooler than the other air. So this is how it works for the air and for everywhere. Like if we talk about a city and there's different areas, so this is how it works. So let's talk about geography and topography. Let me explain what geography is. It is the study of physical features of Earth and its atmosphere, obviously. And that if we talk about atmosphere, so we have all the different adversities like human activities and like everything, our colonies, our buildings, and everything is inside it. So yeah, all of these does matter, and they affect the distribution of air velocity, and I will explain that furthermore. Some examples of human geography include urban geography, economic geography, culture geography, political, and everything as I mentioned earlier. So let's talk about topography. What is topography? Topography is the study of shape and features of land surfaces. The topography of area could refer to surface shapes and feature themselves or a description and arrangement of natural and artificial physical features of an area. If we talk about some examples of topography, we have like mountains, hills, valleys, lake, oceans, rivers, cities, dams, road, elevation. Like as I said, we have to include all the factors, physical and artificial, made by humans and everything. So let's see how topography affects the wind velocity. As I mentioned earlier, we have mountains, so the air gonna go downside down the hill and that is why topography creates distinctive regional winds. As wind descends the leeward slopes, the air compresses, become more dense and warm. Strong winds can result, such as powerful and unseasonably warm chinook winds that flow down eastern side of Rocky Mountains. And how does the geography affect the weather? Basically, geography and topography are the same things, but the difference is like in topography, we can go in more details and we actually talk about the shapes of the landscape. So hills and mountains result in local regions of increased wind. As I already mentioned, this is partly a result of altitude. The Earth's boundary layer means the wind speed generally increases with the height above ground, and hilltop and mountains peaks may project into higher wind speed layers. So as you can see, sometimes we have very high air wind and speed. Astronomers have discovered the fastest ultraviolet winds ever recorded in the universe, swirling around a supermassive black hole at speed of up to 200 million kilometers per hour. That's 125 million miles per hour. We are talking about wind speed of 20% the speed of light. So that was the fastest wind we have in this universe, and now you can see how fast it can go actually. And now, if we talk about area of application, so we have a couple of uses of air that we have been, like the energy that comes from wind, we have been assuming. So here are the some of them. So first we have electrical type, like we use it like for the wind powers, turbines, and also as you know, like we have windmills connected to the wind, like it can appear to be installed in houses, on the roofs and everywhere, and that energy is basically converted into different things. Like if you put batteries, you put a turbine and then you put batteries, so then you can actually change that mechanical energy into electrical energy and other things. So this is how we have made some devices and appliances, and that we can take advantage of the wind energy. So in a small houses system and commercial systems, water pumping, like we have irrigation system that is dependent on wind energy, and then we have like telecommunications, like navigation aids, that is also dependent on this. Wind power, electrical, standalone, enormous diesel, commercial systems, more settlements, mini grid systems. Like these are the types of system like we have for electrical power generation, and we have different type of other things in it. And water pumping, like I already mentioned, like we have a lot of different places where we have installed such systems. For example, in the irrigation system and watering system and drinking water supply. And last but not the least, we have been using wind energy in milling grains. Like there's kind of machine that actually uses the it have a blade, and that turns due to the wind and it produces some power, so you can use this milling machine to for the grains. So if we are going to talk about distribution of wind velocity, so we should be specific to some area. I might give you some example about my own country, Pakistan. So this is a research that I've done my friend, and the data that you have collected. So here we have some different places. For example, we have Jimpur, and that is near to the coast area. So it would be a good example to see because as this is close to the sea, and we have Multan in the center of our country, and that is more like a ground area, like we don't have mountains and anything. And then we have Islamabad, that is a mountainous area. So we're gonna have a good idea like how this works, and the velocities are the wind velocities are distributed throughout the area. So here we have mean annual wind speed according to the areas that we have been given. So I have explained them in detail in my report, how the wind is distributed according to the areas annually. So in Gujranwala, we can see we have around like 1.8 miles per hour speed, sorry, meter per second speed. And then we have Islamabad, and you can see is the lowest we have here, and the maximum is in Katipur Bandar, as you can see, is on the coast. So that's why the wind speeds are higher, and then there are no distraction in the way like the mountains, and so the wind speed is higher. We have Khanewal, Multan, and Sialkot that has been given. So let's talk about the types of wind turbines we have, because as we already talked, like is the application of wind energy that we have been using wind turbines since a long time to produce energy, and basically electrical energy. So here are basically two types of turbines we have, horizontal and vertical. In horizontal axis turbine, it is possible to catch more wind, and so the power output can be higher than that of vertical axis. But in horizontal axis design, the tower is higher and more blade design parameters have to be defined. In vertical axis turbine, no your system is required, and there is no cyclic load on the blade. Thus, it is easier to design. Maintenance is easier in vertical axis turbine, whereas horizontal turbine offers better performance. So basically, we have been using horizontal turbines all over the world, we can say, as it has better performance. So that's it for today. You may now ask questions. Thank you.
Yes, Favor and Afan Muhammad Fateh, if you have any question, you can ask him.
Anton, is it best to put a turbine on the mountain or on the plain?
No, we cannot, because as I already told you, if we go higher above the ground, the area is not very plain. Like we have mountains, so because of the mountains, like let me just present you this. That's a good explanation. So when you see the air is not stable, the speed is not stable. 1 minute you're gonna have high winds, and the other minute you're gonna have low winds, and that's because continuous heating effect from the sun and the cooling effect from the mountains. So the temperatures keep changing, the pressure keeps changing, and the speed of air keeps changing. So you don't have stable air speed there. So that's why you cannot taste it. And of course, some other factors as well we have.
All right, thanks.
Is it clear?
Yes, it is. Thank you.
Okay, you're welcome.
Next, Afan and Muhammad Fateh.
Yes, sir. Muhammad Fatou.
Muhammad Fatu, do you have any question regarding this presentation?
Yeah, I come in the middle in presentation, but no question for me.
No
Thanks, you.
question. Okay, Afan Nadeem, do you have any questions
No,
belong to
sir.
this? Okay, the next one is going to present the favor.
Okay, sir.
Yes, favor, you can open from your side.
Can everyone see?
Okay,
Yes, yes.
you can start it.
All right, good day, everyone. Yeah, firstly, I'll be talking about wind energy based on the design and how wind can be controlled. As we all know, wind is a source of renewable energy amongst many other renewable energies like hydropower, thermal, solar, and so on. So, wind, as my friend explained before, is a form of air which moves quickly from from a state of high pressure to an area of low pressure, and it all occurs due to different factors such as the temperature, the pressure of the air, the centrifugal acceleration. Based on the temperature, based on the temperature of the air, as one know, the temperature of air, it doesn't really stay constant. During the day, the temperature is different from the temperature at night. So these changes, like, they occur due to the change of the way the atmosphere of the earth heats, like the different heating atmosphere, the different heating temperatures during the day is different from heating temperature during the night. Secondly, the air pressure also acts as a factor to determine how much wind we get. The air pressure is the weight of a column or air reaching the top of the atmosphere from the ground. Like the pressure of the air on the mountain top is different from the pressure on the air on the ground. Also, the centrifugal accelerator, this has to do with the force which increases the air speed and also the direction at which the wind flows around the center of circulation. Like if air is moving in a particular area, there tends to be more pressure or more air at the center of the force. Lastly, the Earth's rotation also determines what amount of wind flows in a particular area. Like the Earth rotates around the sun, which we all know. So there are periods of time whereby the wind in an area or in a topography is different from that of another topography. Next, I'll be talking about wind energy. As you all know, wind energy is the energy gotten from the wind, which is obviously clear and is kind of similar but different from solar energy. Because nowadays, the energy gotten from the wind is converted from a kinetic energy which the wind holds into mechanical energy. And that mechanical energy is further converted through the use of wind turbines into electrical energy, which can be distributed for use in different manners. So there are basically three types of wind energy. One, it can be used in a utility scale, which isn't that much of a scale. Secondly, it can be used in a small scale. And lastly, offshore wind. The offshore wind is completely different from the other two. Offshore wind has to do with large amount of scale used to produce large amount of electricity, which is gotten from the kinetic energy of the wind. Next, we have advantage of wind energy. Obviously, it's environmental friendly because it doesn't have any effect to the environment, and it doesn't act like like a factor in affecting our ozone layer, which we all complain about global warming nowadays. It's environmental friendly, and also as I said earlier, it's a renewable energy, which means it's free. It doesn't end, it doesn't finish, unlike our fuel and other source of energy. This it's constant, it renews on its own. And also it has been proven to have high efficiency, but not as high as other sources of renewable energy. This disadvantage, noise pollution. The 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 noise from the wind turbine is really high. So it's why it's not really advisable to place wind turbines in places where people live because they complain of noise and everything. Also, when installing wind turbines and harnessing the energy from the wind, it affects the wildlife, which means you have to cut down different forests, trees, and in order to create space for the wind turbines and airflow. So it affects the wildlife. Secondly, it's less efficient, as I said earlier, compared to other sources of energy, such as hydropower, geothermal, and other sources of renewable energy. lastly, is not really reliable because wind is not something we can rely on. And because wind sometimes we can experience different temperature or weather, so wind is not really constant. Next, we'll be talking about wind turbines. There are basically two types of wind turbines. As we on there's horizontal axis wind turbine or the vertical axis wind turbine. The difference between these two wind turbines is in the placement of the rotor blades. In horizontal wind turbines, is normal to see one blade wind turbine, or but it's usually three blade wind turbine based on horizontal axis wind turbine. But in a vertical axis wind turbine, the blade is aligned in a vertical axis to the nacelle. So in a design of a wind turbine, there are different parts which there are different parts of a wind turbine which have to be produced in order to like allow the wind turbine function properly, such as we have the rotor blade, which we all know, which is the main. To me, the rotor blade is actually the main part of a wind turbine because without the rotor blade, you cannot harness the kinetic energy of the wind because the wind flows towards the rotor blade, which the rotor blades convert the kinetic energy of the wind into mechanical energy, which is now stored in the nacelle. Then nacelle now converts it through the use of generators into electrical energy. Next, we have the tower. The tower is actually very, very important because without the tower, you cannot harness enough wind energy. And the tower also, the height of the tower also determines the amount of power output at which the turbine gets out. The higher the tower, the higher the power output. So when controlling wind energy, we basically use a turbine to control the wind and the energy at which we get from the wind. So the different control methods can be, you have the generator speed, we have the blade angle adjustment, we have the power control, we have yawning, and we have the electrical and mechanical braking. Based on the power control has to do with, we have to control or adjust the best possible variables at which the turbine brings out or maximizes the kinetic energy of the wind. By controlling the power output, we can control the efficiency and also the amount of power at which we want a specific turbine to generate for us. That is for my first topic. Any question, please?
This is your first topic.
Yes, doctor.
Yes, Ayub Shakil, Afan Nadeem, and Muhammad Fateh. If you have any question, ask him. So, in the next presentation, this favor will ask you very critical and hard question. So, try to ask him right now. Ayub Shakil and Afan Muhammad Fateh, if you have asked him questions.
That's clear, sir. No question.
No, sir, we don't have any questions.
No, sir.
Okay, the next one is going to present the Afan Nadeem.
Sir, today we will present only one topic.
You will present only the one topic?
Yeah, no, I am asking, we will present the two topic today or one topic?
Both of them.
Tamam. Okay, sir.
Okay, Afan Nadeem, go ahead.
Can you guys see my screen?
No,
सर नजर आ रही स्क्रीन?
नहीं स्क्रीन ही नजर आ रही. You can see.
सर आ रही थी सर.
मुझे नहीं आ रहे थे.
आ रही है अब?
हाँ आ रही.
एक सेकंड. स्लाइड पर जाओ ना.
हाँ स्लाइड खोलो ना तुम.
हाँ ठीक है.
Sir, hello guys. My name is Afan Nadeem, and today's my topic
Hello.
is like how the electricity is produced from the wind energy. So let me first give a brief about the wind turbines. The wind turbines are known in which blades are fixed to the hub, which drive a generator via a shaft connected to that hub. A wind turbine involves converting wind energy into electricity by using wind turbine. A wind turbine usually has three propellers like blades called rotor. The rotor is attached to a tall tower. The reason for the tower is too tall is that winds are stronger higher from the ground and there is a less buffeting effect. The wind makes the router spin. As the router spins, the movement of the blades drive a generator that creates energy. So let me show you my presentation. Then you will get a brief about
अफान
the
नदीम, अफान नदीम,
yes.
तुम्हारी तरफ पंखा लगा हुआ क्या? हवा आ रही है, आवाज क्लियर नहीं आ रही तुम्हारी.
Okay, sir. Wait. Yes, sir. Now it's fine.
इट्स ओके.
So let me give you a brief about, in my presentation, like how it's work. The electricity is produced. So first, we come on the construction, the foundation. There are mainly two types of foundation: shallow flat disk, which is 40 feet diameter and 30 feet thick. Second is deeper cylinder, 15 feet diameter and 16 feet deep. Foundation is made up of concrete reinforced with the steel bars. Then we come to the tower. As you know, the the electricity production of electricity is directly proportional to the size of the router. So as much the taller will be the tower, the more electricity can be generated. So there are two types of tower: floating tower, the land-based tower. So it is made up of steel. The height of the tower is like about 200, minimum 212 feet to 262 feet. The weight of a tower is from 71 to 220 tons. So there is a like the mechanism of the wind turbines. So the most common wind turbine design is the horizontal wind axis turbines. These turbines contain a central hub fastened to two or three blades. The blades tilt at an angle to split the airflow, making them rotate to sufficient wind speed. Blade rotation causes gears to spin inside a transmission system contained within the turbine. A generator then converts the spinning gear motion into electricity which travels down the wind turbine tower through cables to the electrical grid for storage and distribution. So first we come on the blades. The blade lifts and rotates when the wind is blown over them, causing the rotors to spin. Most turbines have two or three blades, or you can say the propellers. Then the rotors. The rotors and the blade and the hub together makes the rotors. Then we come on the pitch system. It turns the blade out of the wind to control the rotor speed and to keep the rotor from turning in winds that are too fast. Brakes stops the rotor mechanically, electrically, and hydraulically when we have a sufficient amount of electricity. So it helps to brake the uh, turbines to like stop the rotating. Then we have the slow speed shaft. It turns the low speed shaft at about 30 to 60 RPM. Then we come on the gearbox. Gearbox connect the low speed shaft to the high speed shaft and increasing the rotational speed from about 30 to 60 rotations per minute to about 1018 RPM. This rotation speed requires the most generator to produce electricity. The gearbox is a costly and heavy part of the wind turbine, and engineers floating direct drive generator that operate at lower rotation speed and do not need gearboxes. Then the low speed shaft is connected to the higher speed shaft. Together they make uh, the gearbox. Low speed shaft is connected to through the gears with high speed shaft which drive the generator. The generator. There are two types of generator. Variable speed generator. It produces electricity at a varying frequency which must be corrected to 60 cycles per second before it is fed onto the grid. The second one is fixed speed generator. They don't need to Yeah, they don't need to rotate. They are able to take advantage of the fluctuation in the wind speed. The wind wing measures wind direction and communicates with the yaw drive to orient turbines properly with respect to the winds. The ammometer. It measures the wind and the required data to the controller, and then it's from the controller. It starts the machine in at the wind speed at about 8 to 16 mile per hour, 5 to 10 kilometer per hour, and starts the generator off at the maximum of 34 kilometer per hour. Turbine do not operate at wind speed. Then the last part is the yaw drive. The orients upwind turbines to keep them facing the winds when the direction changes. It allows the nacelle and the rotor rotate in the direction of incoming wind to maximize the energy output. So how does the wind turbine generate electricity? So it's a short brief of the slide which I wrote before. So the first part came the blades and the rotor convert the wind power kinetic energy to the rotational mechanical energy. Then come the gearbox where wind turbine rotate typically between 30 rpm to 600 rpm. Generators typically rotate at 1000 to 1800 rpm. Most wind turbine require a step-up gearbox for the efficient generator operation. Then the generators convert the rotational mechanical energy to power electrical system. Then the next question is like after the wind turbine, how is the electricity come to our houses by the wind turbine? So the wire is connecting from the wind turbine to the wings, then it goes to the transformer, it goes to the substation control house, then to the switchgear, and then to the power grid, then to our houses. So the size and efficiency, as you can see in the picture, uh, the small the small wind turbine is uh, is uh, is providing 10 kilowatts, and the highest wind turbine that is 100-meter high it provides 3 megawatts. So the size of the wind turbine is dependent on the production of electricity. As the taller will be the size and the uh, length of the wind turbine, the higher will be the generation of the electricity. So here's the annual energy production formula to calculate your annual energy wind production. This is the formula for your houses or the wind farm, like how much energy you can produce from the for your house or the farm for an year. Thank you for your time.
Okay, where is Favor and Muhammad Fateh Ayub? Ask him if you have any question in your mind.
This information is for horizontal turbine, not for axial, for vertical turbine, or for turbine.
Sorry,
Muhammad,
your voice
Fa-
isn't clear.
Muhammad Fateh, your voice is not clear.
Okay, it's clear now.
Okay, go ahead.
Hello?
Yes, go.
Yeah. This information for components in turbine is for horizontal turbine only or horizontal and vertical turbine.
This for the both of them, because the mechanism is the common. Just the in the horizontal, I just showed you the slide for the horizontal turbine. For the vertical turbine, the whole mechanism is like on the ground, not uh, on the behind of it.
Thank
The whole
you.
mechanism is the same, but the placing are different on them.
Okay, where is Favor and Ayub Shakil?
No,
Yes,
sir,
sir.
thank you. Everything was clear.
Clear, sir.
Yes, Favor.
Just clear.
No question.
No questions.
Okay, Muhammad Fateh, you can present.
Okay, 3 more. Is this here?
Go to on your slide. Yes.
Okay. My topic is about power, wind power. Um, and Still, I don't see. Are you see the slides?
Yes, we can see your slides.
Okay.
Excuse me,
Um,
I couldn't hear the
yes.
topic. What is the topic?
Oh, okay. First, the wind power. Then we can power from and air flow
Muhammad Fateh,
roughly
listen, wait a minute, 1 minute.
Your voice
Muhammad
is not there.
your voice is not clear. Please adjust your headphone
1 minute.
or
Yeah. I will. Okay, 1 minute. 1 minute here, please. Hello.
yes, Muhammad Fateh.
Hello. Yes.
Muhammad Fateh,
You know.
uh,
Yes.
in the starting, what is your topic name? I know your topic names. Tell them to your friend before you started.
Yeah. Okay. Okay. My topic talking about the wind power, and then the vertical turbine. Okay. Um, for the first topic, the wind power, as we know, the turbine run with airflow, and this air, when go into turbine, the turbine produce a power. This power is different between the different turbines, and it's around 600 kilowatt to 9 megapascal. And if we want to make a power from turbine, wind turbine, we should use a place with stable or constant for speed of the wind. It's preferred for the location, like you said in geography topic. And Okay. We use 4% from electricity from wind power. Um, and The wind power, the advantage of wind power is it's not toxic gases or pollution. We can planning for wind power and construction is very easy, and in short time for planning and construction it not required more time like other type of power. The technology for wind power is developed in the previous years. We can say the main idea for wind power is to convert the speed to the power using turbine for electricity, or use or for pumping, water pumping. We will talking about it later. Um, and The power amount of power depends on the rotor size and wind speed, because every turbine had a different rotor. and this rotor, if we use a turbine for a farm or small valves also, we don't use a big turbine. We use a small turbine. It make 400 watt. But if we want this power for companies, we make farm wind power, and this farm wind make up to 9 megapascal for the power. Okay, so we have a capacity factor, and this factor is compared between the power from wind power and other sources like thermal plants or nuclear plants, and so the wind power has a low capacity factor, but its development now to be speech in the world. And in general rule for the wind power, we can take a power from turbine until the speed average is 4.5 meter per second. And if we construct the wind power or wind turbine in some place, we should use this place with a constant speed wind. Okay. We have two applications for wind power. The first is wind pump. The wind pump, we use it in the places they haven't electricity or haven't the places are not in the off-grid areas in the city also, and we can get the water from the earth, but it's depends on the total pumping heat and the daily water we require. But we can power for wind pumps. And second, the electricity. We can use the wind power to make electricity. We have been talking about that, but I want to say here the small turbine electricity can be used for store the power in batteries or in use day or in use direct in the houses or in the companies. But for longer than wind power, it converts the power to make a big hub for a big companies. Okay. And the output power depends on the size for turbine. If the turbine is small, the size will be between 0.5 to 5 meter, and the power output will be between 0.5 to 2 kilowatt. And for the high turbine, it will the diameter will be between 5 to 30 meter, and the power output will be between 10 to 215 kilowatts. And like I said, it's depends what do you want from this power. Do you want this power for houses or for campings? Okay, this graph appears the countries that use wind power in the world. Britannia, Denmark, Bulgaria, Germany, and so. And in the various years, African countries also use the wind power, but solar energy in Africa is become subject for wind power. The first thing, we don't have information on another markets in China or in another lands, and we don't have enough information for output condition like the speed of wind or the and yeah in wind power we don't have enough qualification for stuff in repairing or service. Investment cost. The wind power is for the long time, but for construction, the petroleum power or another power, thermal power, is cost than wind power. Okay, one minute, please.
Muhammad Fateh. Yes, you finished?
No, I want to share another PowerPoint.
Okay, another power part. Okay, you can.
Oh, you see?
Yes, we can.
Here about the general information on vertical axis turbine. As we know, the wind turbine has two has many, not two, has many types. The first is horizontal, and second is vertical. But like I said, the main idea is the same. In the turbine, we use the wind and there's we use the wind and magnetic to make it racing. The wind component, like I mentioned, this component is controlled wind in horizontal and vertical. Yeah. We use in turbine in horizontal and vertical the kinematic wind energy and transfer it to electrical energy. And the main idea is how we use the wind and rotate it around the coil wire or coil of wire with a magnetic field, and then we can take electricity. This type is the horizontal axis turbine. This is the first and the familiar. The second is vertical axis turbine. It's not similar like the first, but at the very clear, it has development changes vertical turbine because we use it for the timber construction. In this turbine, the rotor will work around the axis, but in vertical, and here. The specific advantage for this vertical axis turbine is a simple design, not like another turbine, and we can make this turbine in the very field with aerospace lift or all the aerodynamic aerospace lift, and but the disadvantage for this turbine is the output or the power output is not like another turbine in the horizontal turbine, like this turbine. And this is the information for vertical axis turbine. I am search now for inefficiency.
Yes, Afan, Ayub, and Favor. Any question belong to this presentation?
For I have a question.
Mhm.
For vertical axis wind turbine, what's the major design difference between that and horizontal?
Yeah, the major design difference is the rotor is run or rot in the vertical axle, not like other turbine. And we can construct this turbine with a small components for yeah, it's included the gearbox and other components, but not in the not like other turbine. So we can construct we can build this turbine either than a horizontal turbine only for design or what I understand, but the output is bad as other.
Okay, thank you.
Yes.
Yes, Ayub.
So I don't have any question.
Afan,
Okay.
the one guy is missing Yazid. Muhammad Fateh, do you know this guy? I think this Yazid is Arabic guy.
I can ask about him. I don't know him, but I can ask and maybe I catch him. Yeah. Today I can ask him about him.
So the today presentation is over. We fixed this time. He is absent. I don't know where is it up to them. You can ask him. And
Okay.
now is the remaining this your word file. Send it to me by the email. I will check the plagiarism. If is it more than uh, what we fixed it before, I will send you back. Then you will rewrite again.
Okay, sir, but in them we have homework topics. We will upload this in homework topics or send it to you by